in the right hand direction, or we can say in the clockwise direction. So we need to see what happens to the moment, and moment is nothing but force multiplied by the perpendicular distance of the center of mass of this signboard from the point P. So let's think about the force first. Force is nothing but the weight of this signboard, and weight is nothing but mass into acceleration. Acceleration due to gravity. So mass, if you consider the mass of the signboard, the mass always remains constant. Wherever the object is, mass is always constant. Now the acceleration due to gravity is also constant near the surface of the earth. So if you see the multiplication of mass into acceleration due to gravity, that is nothing but the weight. Weight will always remain constant because this object is nearby the surface of the earth. So there will be no change in this force, because force is nothing but the weight. Now let's see what is the what happens to the r. R is what here? R is nothing but the distance of the center of mass from the point P, and that is the perpendicular distance. So first of all, we will see here. Suppose at the center here, I will assume that this is the center of mass only. So the center of the signboard itself is the center of mass because it is a symmetric body. So when this object will fall in this clockwise direction, this center of mass will also fall in this direction roughly. Okay. So here when the center of mass will fall in along this direction, I can consider these 2 points over here. Okay. And from this point, what will happen? The weight, we can see the weight is always acting in a downward direction. Anyway, the weight is always acting in a downward direction, and it is always constant near the surface of the earth. So R is what? R is the distance, perpendicular distance of this center of mass from the point P. Okay, R is what? Perpendicular distance of the center of mass from the point P. This line is showing you the line along which the center of mass of this signboard will fall once we remove this concrete block. So what is the perpendicular distance from point P? So you can see here, if you consider this point, then you can say this is nothing but the perpendicular distance from the point P. Okay, this is the point P here. The point P line is nothing but this. Okay, and what is this line? This weight line, or we can say the line of action of the weight that is passing through this center of mass. Okay. So this you can say is the perpendicular distance from the point P. So it is you can say I have drawn here for this distance is perpendicular to the direction of the weight, because weight is always in the downward direction. If you consider this point of this fall line of the center of mass, then perpendicular distance will be equal to this. Okay, so you can see here, as the signboard will fall in this right hand direction or in the clockwise direction, the center of mass of this board will go away from this point P. If you consider the perpendicular distance from this weight, this is the weight which is falling in the downward direction. That's why I'm drawing only the perpendicular line and up to this line only, because at this line there is a point P. Okay, because R is what? R is nothing but the perpendicular distance from the pivot. P is like a pivot, and the weight is falling in a downward direction, so I should draw a line which is perpendicular to this weight. Weight is nothing but the force. So this line will increase. So there will be the increase in R. So that's why there will be the increase in the moment, because the force is remaining constant, because the weight is the constant. So here we can write down as the can write down here as the perpendicular distance between point P and the, you can write down line of action of weight. What is line of action of weight? That is nothing but the point where the we can say that is nothing but the center of mass. Okay, because the line of action of weight is passing always to the center of mass. So that line, that perpendicular distance, if it increases, then we can say the moment moment about point P will also increase. So moment is force multiplied by perpendicular distance. So force, that is weight, is constant, but the perpendicular distance from the line of action, you can say here the line of action, from the line of action of the weight will increase. What is the line of action from the weight? That is nothing from the center of mass, because the weight is always passing through this center of mass. Weight is always acting through this center of mass. Weight is acting is nothing but the line of action. Okay, so this you can say this vertical line that is showing the or downward direction line is nothing but the line of action. Okay, so the distance from this line of action towards the point P is nothing but r. So this is nothing but the r. Now we'll see the second question here. So figure 2.1 is a head-on view of the airliner flying at the constant speed. You can see this is flying at the constant speed in the circular horizontal path. This is very important. The center of the circle to the left of the diagram. So here question number A. On the figure 2.1, draw the resultant force acting on the airliner and explain your answer. So we need to draw the resultant force. What is the resultant force? It is nothing but the addition of all the forces acting on the airliner or any object. Okay. So whatever forces are acting on any object, we have to add them, and whatever one single force we will get as a result is called as the resultant force. So first of all, see you can see here the airliner is moving in the horizontal circular path. The circular word is very important here, because whenever any object moves in a circular path, there is a force which is acting on that object toward the center of the circle is called as the centrifugal force. Here you can see the reference diagram is attached over here. So this is a circle and this object is moving in a circular path like this way. You can say it is moving in a circular path. So you can consider any circular motion, like you can consider the earth is revolving around the sun, or the moon is revolving around the earth, or you can consider this is a stone which is attached to the string, and you are rotating that in a circular path. Okay, whenever there is a circular motion of any object, there must be the force which is called as the centrifugal force, and that centrifugal force always acts toward the center of the circle. Okay, so here you can say it is flying in a circular path. I can consider this is the like circle along which the airliner is flying in a circular path, and can consider here somewhere it is the center of that circle, imaginary circle. So this airliner should be acted upon by the force which is called as the centrifugal force, which is directed towards this center. Okay, so we have to draw this. I am rubbing this line, and I am drawing the one single line which is acting from the airliner towards the center of this imaginary circle. Okay, and we have to show the direction, because centripetal forces are always directed toward the center of this imaginary circle. Okay, so I hope you understood. There is some circle like this, and this is the center of that circle, and this resultant force is nothing but this centripetal force, which is addition of all the forces which are acting on this object. Okay, once the object is moving in a circular path, there must be the centripetal force. And how we can explain this answer? We should write down over here. Since the airliner is moving along the circular path, it must be acted upon by the resultant force, that is nothing but the centripetal force, centripetal force which is by default